And welcome to the quickening. It's today's daily space weather video, and thanks for tuning in, viewers. This view is from the SDO. It's 171 angstroms plus the colorized magnetogram. We've got a new sunspot rising, and the Earth has been spinning faster once again. Another record set on July 27th. We'll get to it, and lots more on today's daily space weather. Let's subtract the 171 angstroms and view just the colorized magnetogram. This area up here, not a sunspot. This area down here has been named. It's sunspot 3070. 3068 has been mostly stable here over the past 24, although we've got some field complexity happening around the leading umbra. And a new sunspot here, it'll be known as 3071, just risen. We'll show you some close-ups of that. Here's some composite imagery in 211, 304, and 171 angstroms from SDO. 2 species of ionized iron and 1 species of ionized helium. By the way, the music you're hearing is known as Gem Cutter. You can find it on YouTube, Spotify, and all over the internet. Golden Cap Productions is our record label. Let's take a look at volcanoes here. And continued seismic activity here under southwestern Iceland. A 5 magnitude quake happened, as well as a foreshock. Let us know in the comments if you think a major eruption is coming for southwestern Iceland. Karimsky exploding on the Kamchatka Peninsula. That's an uptick there at Karimsky. 25,000 foot ash plume, flight level 250. Shivaluch also erupting on the Kamchatka Peninsula explosively. Flight level 150, it's a 15,000 foot ash plume headed down to Kyushu, Japan. Sakurajima erupting. 8,000 foot ash plume from Sakurajima. Dense and dark ash plumes. They have been as tall as 13,000 feet above sea level. Subanose-jima. Unknown volcanic ash cloud from Subanose-jima. And headed down to Indonesia, we see Mount Ibu exploding, flight level 070. It's a 7,000 foot ash plume. Now headed down to this side of the world, the Americas. Fuego in Guatemala in Central America exploding, flight level 150. It's producing a 15,000 foot ash plume. Sangay in Ecuador, as well as Revenador, both exploding. 20,000 foot ash plume from Sangay. 15,000 foot ash plume from Revenador. Please don't pole vault the caldera. Sabancaya in Peru rounds out our list here in an explosive fashion, producing a 26,000 foot ash plume. Flight level 260 over Sabancaya. Let's get back to the sun, but first, seismic information. Yes, there's the past 90 days, a convenient bar graph from volcanodiscovery.com. And let's briefly scroll up the list here. No major quakes, but quite a few quakes there around the western Pacific. And a fine example of a foreshock. So a bunch of high-level 4 magnitude quakes there happening. The largest of the past 24, I believe, was this 5.3 at the Solomon Islands there. So northeast of Australia there. And here's the most interesting one, a 4.8 magnitude foreshock, followed by a 5.1 at Iceland. So that 5.1 happened at 2:27 this morning on August 2nd. Again, let us know in the comments if you think a major eruption will occur soon in southwestern Iceland. Oh, it turns out the largest quake of the past 24 just occurred at 5:24 Universal Time this morning. A 5.4 at the Philippines. And back to Iron Star. This is the 171 angstroms wavelength from SDO. Again, we've got a new sunspot having risen down there in the southeast. Sunspot 3086 is getting more complex, perhaps preparing for some flaring. That thing is glaring. That's extreme ultraviolet light, by the way, 171 angstroms. Not detectable from the planet's surface. That's why we use spacecraft to view these wavelengths. There's a close-up of sunspot 3071 as it rises. And how about a close-up of 3068? We'll have more of that momentarily here. Radio flux now up to 95 solar flux units. There's the 1-year chart of the radio flux from Solon.info. And Space Weather Enthusiast dashboard here forecasting some periods of geomagnetic unrest late in the day today on August 2nd and early in the day tomorrow, Wednesday, August 3rd. So just before and after midnight, NOAA expecting some geomagnetic unrest here because of coronal hole high-speed streams, I would suspect. Let's take a look at Earth's geospace here. This would be the last 4 hours of Earth's magnetic moment from space. Toward the end of the video, we'll talk about Earth's rotation. Why is it that Earth is spinning faster? What makes Earth spin faster and slower, you may ask yourself? We'll get to it. Here's Earth's magnetic moment from the ground, the last 4 hours. And things remain geomagnetically calm at the moment. If we do see some geomagnetic unrest late in the day today and early in the day tomorrow, we may see some aurorae. That's the last 4 hours of the ground level, ground magnetic perturbations. So KP actually at 3 at the moment. Still what we would call a geomagnetically calm condition. And let's move to the real-time solar wind. So current conditions here are 12.3 protons per cubic centimeter for the solar wind density. Solar wind speed slightly elevated here at 477. Make it 497 kilometers per second. At the moment, not a super powerful coronal hole high-speed stream. Next, looking at some magnetic data here. This is the GOES magnetometer on the GOES 16 and the GOES 17. Fairly smooth readings there. And by the way, Earth has just entered into a North Pole current sheet. So here's the polarity of the solar plasma, part of our Gong 2 data, which is part of the National Sunspot Observatory. And the top view ecliptic plane field plot is showing us that Earth has recently snapped into a North Pole current sheet shown there in green. So here's the latest image. As forecast yesterday, North Pole current sheet is here. South Pole current sheet headed toward stereo B, which is this location here, Lagrangian point 4. So here's our line of sight field plot. And this is yet another reason to follow us on Twitter, because you'll see things you won't see elsewhere. So censorship or not, we probably won't ever get banned from Twitter, like certain idiotic, phony, wannabe space weather channels. So, here's one of our retweets from last night. Shout out to Scott McIntosh. South solar polar field migration ahead like cabbage and onions coming up strong. North solar polar field migration behind, which means plenty of additional activity remains on tap for the exciting solar cycle 25. The sun's not shutting down, folks. So here's our line of sight coronal hole plot, and we've got 2 spectacular views from SDO in terms of coronal holes. North Pole coronal holes rotating in, and we're getting quite a lot of coronal hole coverage now. You can see those trans-equatorial coronal holes there over there in the east in green as the solar polar field migration continues. So these are South Pole-oriented coronal holes, and these are North Pole-oriented coronal holes. That's 193 angstroms. We'll also show 211 angstroms today. They'll be even better defined in that wavelength. So there you go. Great view of coronal holes there. And next we'll move to sunspots. And indeed, Sunspot 3070 got a name. It's actually shrunk. In fact, I think it might have evaporated entirely. But we do have Sunspot 3071 now rising in the south. Again, 3068 has gained some magnetic complexity, so the likelihood of it flaring has actually gone up a little bit here. We've got some significant North Pole oriented plasma right around north and south of that leading umbra. Here's the rising of Sunspot 3071. And here's Sunspot 3068. Fantastic close-up there on the SDO continuum. And allow us to pause for station identification. This is SNN, the Smash News Network, least busted name in news. Whew. So the flaring profile has come up here. We did see looks like nearly a C-class flare happening there while we did show prep. And you can see this little uptick here. So solar activity rising a little bit here. The radio flux came up, as we said earlier. 95 solar flux units is now where the radio flux is. And the X-ray profile increasing as well as a hotter portion of the sun rotates in. Here's a great wavelength to view X-rays, 131 angstroms, another species of ionized iron. And we'll show you another composite imagery set of images of Iron Star here toward the end of our at the end of our space weather coverage. Before we start talking about Earth's speeding up of its rotation, we've mentioned it many times in the channel, and we will get there. So no relativistic protons at the moment. Proton flux remains flatlined. By the way, this video was originally streamed live to Twitch. If you haven't checked it out, maybe install the mobile app. Twitch.tv/Smashomash is the location of the regularly live streaming station. Thanks to everybody who follows us over there. And thanks to everybody who views the content on YouTube. Please press like and subscribe. Tell your friends and foes about us. Press the notification bell. You may actually receive a notification when we put up a video. Who knows? Once again, thanks to our YouTube viewers. Today's featured product is, if you want to help out the channel via merch, hit us up with some merch. Check out the Mensa products. This is today's featured product. And part of the reason why we have a channel in the first place is to advance the science, to provide interesting coverage and facts. A resource for people to understand what's going on in the realm of space and Earth, aka space weather. Also Earth weather, thrown in as an additional feature. We're out here trying to make Earth not suck again. So perhaps start a conversation with our rather provocative merch. Because folks, our finest days lie ahead. So don't be fatalistic. Make Earth not suck again, like we do here at the Smash News Network. And what I'm wearing today is, can't say certain words, so make Earth not suck again. It's up to you. One of the ways you can make Earth not suck again is by helping us out by becoming a subscription service member at the gold or silver level at smashomash.com/smashteam. You know, the Germans in the 1930s and 40s thought they were free, and they slid down a slippery slope. Click posts to see our latest posts. That one doesn't even require any login. That's for everybody to view. You can find links at our homepage at smashomash.com. And once again, I would say to each and every one of you, welcome to the Neo-Renaissance. Don't pole vault the caldera. If you're going through hell, keep going. Because let me reiterate, our finest days lie ahead. Smashomash.com to find our links all over social media as we encourage you to look up. Now, if you look up over the Lehigh Valley, this is what you might see. I think it might be cloudy, but if it was clear, what's up there is Saturn, Jupiter, Mars, and Venus, all near the ecliptic there as the sun has just risen. Did you know that this star right here is actually a massive X-ray binary known as Cygnus X3? Well, that's the binary portion. It's known as Deneb. It's the brightest intrinsic object visible from our solar system. And it's possibly the only known cosmic ray source, Deneb. Gobekli Tepe is oriented to it, and we've got a whole entire forum thread about it at smashomash.com/forum. Next, headed to our solar system forecast. We're going to show you where things will be. Mercury is coming around to say hi once again. Let's do the 1 week forecast for the solar system. Keep in mind, this chart is not to scale. There's where things will be. In a week, we will have a gibbous waxing moon. And let's look at coronagraphs. So no additional CMEs headed toward Earth at the moment. We do see some minor coronal mass ejection features. Again, we don't anticipate any of those being Earth-directed. That was yesterday, August 1st. And let's show today. This data from George Mason University, by the way. And there's today's coronagraph to date. That's 33 frames of CME activity. And we'll also show the view from Stereo A as we do most days. Stereo A located here at Lagrange 5 will be on your left. Soho Lasco C3 located here at Lagrange 1 will be on your right. And the coast is clear when it comes to coronal mass ejections headed toward Earth. For you new viewers, Earth would be off in this direction. Somewhat on this line right here, slightly north of the equatorial solar plane, but approximately in that orientation. So no CMEs at the moment. Let's take a look at solar filaments here by looking at hydrogen alpha imagery from the ground-based solar observatory at El Teide, Spain. Some filaments down here in the south. And again, likelihood of flares actually coming from sunspot 3068 have gone up as it is gaining magnetic complexity. I believe it is now beta gamma delta class. Some huge filaments showing up here as well in the northeast. You can see that prominence there. Filaments, prominence, they're essentially the same thing. Another filament in the north portion of the solar disk. So here's this prominence. Great view of that in the wide field of view from the GOES 16 SUVI. Looks like some of that ejecta has collapsed back down toward the chromosphere. But that prominence continuing, and it is quite large. You can see a lot of overhang here. Huge series of activity happening up there. There could be a sunspot rising there behind this plage. So here's the that was about 2.5 hours. This is the last 24 hours from SDO, the higher resolution and narrower field of view. And let's go to the bonus features segment and blast through those. So here is our Satellites Community Dashboard. Minor charging hazards here over Mexico once again, just like yesterday, caused by low energy electrons building up on the surfaces of satellites. Minor charging hazards moving into the Central Pacific. Here is the GOES electron flux over the past 3 days. We see a little lower levels of electron flux here as we've had some minor coronal hole high-speed streams. Here is the forecast model from NOAA. You can see NOAA missing a little bit there. The relativistic electrons a little bit lower than NOAA's forecast, which is the green box. Here's the 1-year chart from Solon.info, and you can see, again, a little lower levels of electron flux here, consistent with coronal hole high-speed streams. We'll also show the F ionosphere layer located at about 300 kilometers of altitude. Here is that in vibrational frequency, megahertz, millions of vibrations per second. It's very diffuse, the atmosphere at 300 kilometers of altitude, and it's subject to high levels of vibration, especially around the equator at noon. Let's reload that. It just stopped playing because reasons. This is from Australian Government Bureau of Meteorology. And the F ionosphere layer is in many ways the bridge between Earth and space. So here's the anomalygram, and we're seeing some low-frequency anomalies, mainly around the equator and south of it. Also some over Mexico and the Central Pacific Ocean. Some pretty significant shifts there from high to low frequency anomaly around the Arabian Peninsula once again. And let's bring up the latest image. There's 1015 universal time ionogram. There's 1015 universal time anomalygram. Next, the total electron content forecast, showing you the most likely spots for GPS errors. It is the coupled thermosphere, ionosphere, plasmasphere electrodynamics model, showing you all the free electrons between your GPS satellite and your handset. No major anomalies there, some around Antarctica though, some minor ones. So there's a diagram just showing you distances to things in miles. Feel free to pause the imagery there on that frame if you're not familiar with things like the altitudes of the inner and outer Van Allen belts. Here's our latest intensitygram and our latest colorized magnetogram. Here is Sunspot 3071. It appears to be an alpha class sunspot at the moment. I only see one polarity umbra there. And let's take a look at 3068. And again, you can see these new fields forming right around this leading umbra. It is now beta gamma delta class. Likelihood of it flaring goes up a little bit as a result of that. There's the rock back. You can see those green areas north and south of the leading umbra of Sunspot 3068. Let's bring up one more series of images here from SDO. This is Iron Star. 3 species of ionized iron. It's 94, 193, and 335 angstroms. And that is where we will need to end today's space weather content, because there's some interesting facts to talk about when it comes to Earth's rotation. So that's actually a climate feature. I guess I'm still allowed to say the word climate on YouTube. So thanks for leaving a comment, Tinman1057, and good morning to you as well. So let's get into this. The Earth, it spins rather slowly, right? Well, sometimes it spins a little quicker, and quicker, and quicker, and quicker. And well, how fast is it spinning now? As fast as it's ever spun since records have been kept on it. Well, we're going to get to that in a minute. First, we're showing Saharan Dust. You can see Saharan Dust making it all the way into the Caribbean, northern South America, even to Florida. Saharan Dust, it's fertilizing the landscape. And some dusty conditions there in southern Australia as well. So let's take a look at the jet streams here of the eastern world. Highly concentrated jet stream there over especially Western Australia. And a powerful low here in the Southern Ocean. Jet stream's a little incoherent in the northern hemisphere there, sort of all over the place. And let's take a look at the surface winds. There are the surface winds. You can see this powerful low pressure rotating clockwise here. Some strong offshore winds here. If anybody's surfing there, it might be quality surf in southern Australia. Is anybody even there? I don't know. It's a desolate country. I know the population is highly concentrated in the cities. Anyway, here is the, I'm not an expert in Australian geography. Here is the surface wind scenario for the Americas. Strong winds here around southern South America as well. Southern Ocean pretty active here in terms of winds. Here are the jet streams. We've got an anticyclone here over the southwestern U.S. Once again, you can see that clockwise rotation there, an indication of upper level high pressure. Are you under pressure? Here is the jet stream scenario for the central world. Jet stream continues to blow backward over the northern Indian Ocean as well as northern Africa. You can see the jet stream there blowing from east to west. Strong doubled up jet stream there over the southern portion of the planet. Here are the surface winds. And we've got a strong low there between Iceland and Ireland. All right, so Earth sets record for shortest day. You can find an article here on time and date about it. Shortest day of the atomic clock era. It completed one spin in 1.59 milliseconds less than 24 hours. What's up with that? Why is it? Anybody guess why the planet spins faster or more slowly? We do know stuff about this, believe it or not. And I read about this years ago, and we've talked about it repeatedly on the channel. Those videos typically did not gain much traction. So there you go, the shortest day since records have been kept. Why is it happening? Well, it could be related to the Earth's outer layers like oceans, tides, or even climate. Yeah. Did you know that hot water takes up more space than cool water? Yeah. So, here's one paper about it. Historical eclipses in Earth's rotation, because we've actually got some information about what was happening thousands of years ago in terms of Earth's rotation, because we can calculate where planets were, when eclipses would have occurred, and historical counts of eclipses. So that tells us something about things like Earth's rotational speed. And there have been long-term studies about this. Feel free to read the paper. And again, the title is Historical Eclipses and Earth's Rotation, published in April of 2003. Now, NASA affirms this, and here's a little bit of facts about it. If all of Earth's ice melts and flows into the ocean, what would happen to the planet's rotation? Well, guess what, folks? It would rotate more slowly. It's because Earth's rotation is associated with Earth's equatorial bulge. If Earth's equatorial bulge shrinks, the planet rotates more quickly. So yes, the same as when a ballerina or when a figure skater is spinning and she pulls in her arms and spins faster, Earth spins faster as well. So what can we think of that would make the planet spin faster? If the equatorial bulge shrinks, there's either less water in the ocean, or the water in the ocean is colder and hence taking up less space. That's the most likely factor. Now, it could also be caused by things like electrodynamics, magnetohydrodynamics between the outer core and the Earth's mantle. That is another theory behind it. But a known thing is that, for example, if Greenland's ice sheet entirely melted and flowed into the oceans, it would cause the planet to spin more slowly. What's happening now is the opposite. Would that be because the oceans are colder? Would it be because there's more ice forming at the poles and on various ice sheets around the planet? Known facts covered once again, such as if all of Earth's ice melts and flows into the ocean, what would happen to the planet's rotation? It would slow. So, quite the opposite. Maybe ice is being deposited on ice sheets as opposed to in the oceans. Or maybe the water's just colder. But it's certainly not hotter, because if it was hotter, Earth would be rotating more slowly, not more quickly. Period. Facts. So here's our weather.gov map, and unfortunately we're seeing additional flood watches in eastern Kentucky and large portions of West Virginia. Some flash flood warnings there in West Virginia, as well as in southern Ohio. That is very unfortunate. People are dying as a result of flooding. If you're in an area that's going to flood excessively, please leave the area. Your possessions are not worth it. Take yourself, your pets, and your family and get out of there. Water is not very forgiving. If your county is lit on the weather.gov map, please head to weather.gov and click your county. Figure out what your warnings are and heed them. Here's a flash flood warning in central Illinois. So here's our total accumulated precipitation based on the GFS model for the next 72 hours, and you can see additional rains forecasted there. So bad times, some heavy rains also forecasted for Alabama, Mississippi, Georgia, and Florida. Even southern Arizona going to see a few inches of rain there in portions. Missouri going to see some 3-inch plus rains, maybe as many as 4 inches. Once again, that's your 72-hour GFS total accumulated precipitation forecast, brought to you by the Smash News Network, least busted name in news. If you're wondering if that's a dig on CNN, it indeed is, since CNN is the least trusted, most busted name in news. And thanks for leaving comments, General Disturbance. Here's your NASA GOES lightning mapper, and check out the extreme lightning here in southern Illinois and southern Indiana. Yowzers, that is a heavy lightning storm there. Very, very dense lightning there. And let's take a look at a real-time lightning map since we are streaming live at the moment. So we do indeed have some terrestrial lightning here around Decatur. There is thunder rolling in to Decatur. Anyway, there's your global lightning map from lightningmaps.org. Next time you hear thunder, perhaps check it out. And here's your windy.com map. Significant anticyclone continues here in the northern Pacific. Significant low pressure here between Ireland and Iceland. Windy.com, they got a great mobile app as well. Here's your weather.gov map for radar, radar.weather.gov. Very powerful storm there in Saskatchewan. We'll focus on the lower 48 for the remainder. Here's your shortwave radiation map showing clouds and fog. And here's the water vapor. As you can see, the jet stream pushing some cold air down there toward Kentucky. And it's creating massive pressure gradients. You can see right there, huge pressure gradients there right at the Indiana-Illinois border. Here's your recap to close things out. Doppler radar shows vertical motion of water droplets in the air column. They're ground-based systems, unlike this imagery, which is satellite-based, showing the 3.9 nanometer bandwidth of infrared radiation. 3.9 nanometer band, I should say, of infrared radiation, showing clouds and fog. And here is water vapor, showing all of the water vapor, not just that which is condensed onto clouds, but all of the water vapor in the atmosphere. Another satellite-based system. And once again, thanks for tuning into the Smash News Network, least busted name in news. May that solar wind be at your back, and may those facts be present on your YouTube.